Hello and welcome back. Now, last episode ended just a few minutes ago. We got textures imported and being rendered. So, this episode, I want to start the GUI class, which we're going to be doing the GUI draw textures. Yeah, draw texture. So the draw texture class in the GUI class. But we also need to organize some of this mess. Well, I mean, it's not really a mess, but currently we only have one package, and it's just called engine, which I like to put all of my core engine stuff, for instance, like um, application, core, mesh, texture, shader, all those classes I like to put inside of the engine package. But there's a few other packages we're also going to want. So create a new package. I'm going to call it, let's see, need an editor package. Yeah, let me cheat. Because like I said, I'm winging everything, so editor, we need a GUI package. And we need a math package for now. Go ahead and do math package. And that should be all the packages we need for now. We're not going to be doing, because I mean, the engine we're building right now is going to be different from the engines that you see here, the ones that I use, the ones that I've made in the past. It's going to be programmed differently. It's going to handle different things. Because I'm not going to create the same thing twice. That wouldn't make much sense. So I'm going to throw mathf inside of the math package. And yes. So now we have that one in there. Throw the matrix inside of the math package. And always update the references. Now, I think that's, I mean, I could throw color in there. Yeah, I'll throw color in the math class too. Why not? All right, so that organizes that a little better. And the first thing we're going to do is create a GUI class inside of the GUI package. So I'll call that GUI, because we will be able to use this class inside of the game, like your game of your choice, whatever you make with this engine. But the main core reason for it is going to be for the editor. But you'll be able to use it in game too if you want. we're going to create something that's going to be using this, but to be able to bulk it so that it can all be rendered at once and it won't be very intensive on performance. Uh, Now, so we can set up initialization, because this is going to be a static class. So let's do public static void init. So we can tell our core class to initialize our GUI. And then after that, I'm going to say public static void prepare. So initialize is to initialize it, kind of like a constructor. And prepare is, so you're only going to call init once. Prepare is going to be called before you start rendering anything. So it's the preparation phase. So once you call prepare, then bam, you can call any of your GUI methods and it'll do its thing. So inside of initialize, we need the mesh. So we're actually going to change or move around a lot of the information that is inside of these classes. So what I need is the... Ooh, I probably need the shader too, don't I? I probably don't need to store. Oh, yeah, I do. All right, so let's go mesh equals no. We'll just leave it as mesh. Import mesh. And we need a shader. And this is only the mesh for the GUI, like how we explained before, how the coordinate system is going to start up here for GUI, down here for scene stuff. And the shader, this shader is going to be GUI specific. Nothing towards the games that you make with it whatsoever. That is this entire resources folder. This entire resources folder is only for the editor. So don't worry about, oh, well, this is labeled shaders in here and this is textures, and what if I have 1,000 things that is inside of one folder? It's going to be horrible. Well, this is just for the engine itself. Whenever we build the engine further, anything that you're going to have for a game is going to be outside of here. It's going to have its own folder inside of your documents or wherever you're wanting to put it. So you're actually going to have a whole game folder, and it won't be name specific. It'll be just like Unity, where you can create 1,000 folders and have millions of different things in there or whatever, and it'll just individually pick them out and put them where they're supposed to be whenever the engine launches. All right, so inside of the initialize, we need to strip out this. We don't need that anymore up here. So we're going to strip that out. We're going to put it inside of the GUI class. Except for how these are identical, well, there's no point in having two arrays that are identical to each other. So we're just going to reuse this. Let's say mesh data take that from float. All right, there we go. So then we can say mesh equals new mesh and then pass in the mesh data. Oh, mesh data twice. Duh. Mesh data. There we go. So new mesh, mesh data, mesh data. And private static. And private static. So we don't need anybody or any other script accessing the mesh or the shader. Only this script is going to have access to that. So we could just keep that to private, but it needs to be static because we're using these static functions. Let's see. Call shader equals new. No, we'll just, I forgot what I called it, so we got to take it out of here anyways. Let's see here, mesh equals new mesh. Copy. Oh no, I'll just rip it. All right, we don't need this right now. We're going to add something similar later, but it's going to be a GUI skin, just like how Unity has it for their on GUI functions. So you'll be able to skin boxes and windows and all that stuff, but we won't have to worry about that just yet. What in the world? Yeah. Okay, so that builds our shader. Now we need the prepare method. So I'm going to be using GL disable, which actually I think almost everything we're going to be using right here is all GL11. So let's do import Java game library dot OpenGL dot. Hey, am I doing that right? Yeah. Let's just copy that. Let's cheat. There we go. All right, so we'll do GL disable GL. Why do I keep doing that? Depth test, not text. There. So we're gonna disable the depth test. We're not gonna need it. We're gonna draw everything based on the order that we're calling it in. All right. Now need to, let's see here. Need a matrix as well. Let's cut all that out of there. Paste it in there. So bind the shader. Pass in. All right. Here we go. Create a new variable, and we're going to call public static color go background color. And not, wait, am I mat cut. Okay. We're going to default it to color.white. So at runtime, we can actually change this at any time that we want, and it'll stay there. So shader.setUniform, pass in the background color. Now we need an orthographic matrix, which, let's go into the application class, add a get method for these two, because we don't have that yet. So do public static int width, and do return width, and public static int height, and return the height. Now these values will change as you're like stretching the application, because you're going to be able to resize it. But we're going to add that function later, because it's really not dire in any means for right now to add that function. All we need to do is just get the width and get the height. So, say application.width application.height. I don't like creating that over and over, so private matrix 4x4 ortho. We'll just set that in there. Oh, because I didn't make it static. Alright, so sets the color that we're going to be using. And that sets the orthographic matrix. Sets it into the shader. Now, what am I missing? Actually, I think that's it. Alright, another thing we need to do is inside of the mesh class, I do remember this, I made a render method, and I actually did not put a bind method. Public void bind, which the bind code is right here. So I'm going to cut that out of there, put it right there. So we need a way to unbind the mesh, because we're going to be using two different meshes. One for GUI, one for scene, but we've talked about that a million times. So, public void unbind. And this is the actual render code. That's all it is. Right there. That just renders it. This binds it. That unbinds it. Alright, so that fixes that then. Back into our core class. We need to move a few more things around. So mesh.render, we're not gonna unbind it. So initialize, prepare, we need to close it at some point so we can unbind everything. So public static void, we'll call it unbind for now. May change that later. So now we can unbind whatever it is. What's that? No, I had that wrong. So I'm going to say mesh dot unbind. I'm not going to worry about the texture right now. We're not gonna mess with that. We will do that in the core class for now. We'll add a method in there later that does that, but right now it really doesn't matter. So let's go ahead and I didn't save it. All right, mesh.render, no. Now we need to say, we need to initialize GUI. So GUI dot init. And after it clears, I'm going to say GUI dot prepare. And that's going to prepare everything. I don't think I even need that texture dot bind. Yeah, never mind. I don't even need this. There, so now we just say GUI dot prepare. Go into GUI. Now we can actually start creating the GUI method for drawing textures. And it's actually fairly simple. Actually, let's see if... No, we'll just bind it and unbind it. Who cares? Okay. So now we can create the method. So we're going to say public static void draw texture. And then what we're going to need is the texture that we're going to be drawing. And we also need a position on the screen at which we will be drawing to. So float x, float y, float float y. Oh, yeah. Float h. So this is basically just a rectangle, which I probably could just go ahead and create. Let's go ahead and create a rect class, because we're going to need it anyways here very, very shortly. So instead of doing that, we can just call a rect class. And it's going to be super, super easy. It's just going to be public float x equals 0. We always want to initialize float y equals 0. Public float width equals 0, public float height equals 0. So that way we initialize it to the x. Are you kidding me? Yeah. We don't need to initialize it because we got a constructor. Public rect. And then in the constructor, float x, float y, float w, float h. Now we just set this information. So this dot x equals x, this dot y equals y, this dot width. I don't need this. I don't want to put it unless I absolutely have to. So I could do width equals w and height equals h. Whenever my computer wants to stop being a flaming dildo. There we go. Width equals w, height equals h. And that's all we need for right now. And then we can just pass in a whole rectangle right here. So rect r. So the rectangle that we're going to be drawing it in. Import that texture. All right, so inside of the draw texture, we're going to set some variables inside of the shader as well. So, hate messing with all this stuff. Do shader dot set uniform. We're going to be calling an offset. Yes. We're going to be calling an offset because we need to change that variable. Anyways. Or I could just do this. This is the next function we're going to be creating. We'll just call this because it's going to be doing the exact same thing as texture. So instead of hold on, with text chords. Any of you who have ever used Unity most likely knows this function right here. So I'll have this function call this function. That way I'm not typing it multiple times. So inside of here, we pass in the texture that we're going to be doing. The rectangle that we're going to be drawing it in, and then the rectangle of the UV that we're going to be rendering. There we go. So then I can actually just, inside of this function, I can say draw texture with text chords. And I'm going to pass in the text, pass in the rect, and then new rect 0011. And that will be the entire image. Syntax error, oh, okay. So then it'll tell it to draw it with the texture coordinates of 0011, which is the entire image. So now all we have to do is just do this function. So instead of doing it here and doing it here, we can just do it here. Alright, inside of draw texture with texture coordinates, we need to set offset uniform. So shader dot set uniform, then call offset, and say let's make this shorter. Let's just call EV. We'll say UV dot X, UV dot Y, UV dot width, UV dot height. So then that sets the rendering UV of the image that we're going to be doing. We do not have that yet, so we will do that here in just a minute. We'll add another function inside of the shader to be able to pass in 4 floats. Next, we need the scale. So we'll just call it, no, I'll call it pixel scale, because it's the original size of the thing. Don't mind me, I'm just talking to myself. Alright, so set uniform. Pixel scale. So rect, no, drawing rect. So draw rect dot x and draw rect dot y. Oh, that's the position. What am I doing? Scale is height and width. And this is position. I'm going to pass in the position, pass in this pixel scale. Need to pass in the color. Shader dot set uniform. Jesus. Matte color. And what do I call it? Background color. Because since you can change this color at any time, then we need to set the color every time unless the color is changed, which we will mess with that later. But for now, we need to change the color every time because we don't know if we say draw this texture and then change the color and then draw this texture and then change the color and draw this texture. So we need to make sure that the color, or to set the color every time, because we don't know if that color has been changed or not. But later we'll add a method in there where it checks to see if the background color was changed, and we'll also do that with textures so that we're not binding the same texture as well. So it'll make it a little easier for us. So now that we set the background color, now we need to just call mesh.render. And I didn't do anything with texture, did I? No, I did not. So up at the top of this function, we need to call GL bind texture, GL underscore texture underscore 2D, and then pass in the ID of the texture, and that will bind it for us. After we bound that, we'll go ahead and we bound the shader. Yeah, we bind the shader and prepare, so we don't even have to worry about binding the shader. Alright, so then that will bind our texture. So the next thing we need to do is inside of our shader class. Come on. We need some set uniforms in here. So first thing we need to do is do a set vector2 pass in the name. We'll do float x, float y. So if we need to pass in some values to a vector2, we can do that. I'll do int location equals the same as below. GL get uniform location, pass in the program, the name, and say if location does not equal -1, as we screwed that up before. I'll say GL uniform 2F, pass in location, say X and Y. And there's our vector2 method. And so we're not doing it again. Now we need 4 values. So float W, float H. Float Z, float W. Which is exactly the same as the color class. Program equals name, GL uniform 4F, X, Y, Z, W. There we go. That does that. And why am I still having some issues with the GUI? String, float, 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 float. It did add. Wait. I called that something different, didn't I? Oh, stupid me. It all needs to be the same. Set uniform. Set uniform. There, that gets rid of it. Oh. Alright, now we need these variables inside of our shader. There's our fragment shader. There's our vertex shader. So I need some new uniforms. I need uniform vector 2, which is pixel scale. And uniform vector 2 position. Ooh, I can't call that. Let's change that name. Screen position. Now we got to go back into here and make sure that we change. Where do I put it? Change this, because this needs to match up. Screen position. We have a uniform vector 4, which we called offset. You know what? We're just going to cheat on this shader. I think let's close some of this stuff. GUI shader. I think these are very similar to each other. Position color, out color. Yeah, it's very similar actually. So we're just going to cheat and for the texture coordinates, how we're going to do that is we're going to say UV chords equals copy that. Did I multiply that? No, it's just that. And then change UV to texture chords. Just because I want to make sure and get this right. So I don't want to extend it any longer because you don't normally do this shader very often. Normally when you get the GUI shader for the editor, you just leave it alone. And normally you just use it for project to project. So just to make sure that I get it right, I'm going to copy this. Normally I just wing it, but as you can tell, it takes a little bit of math, especially with the way that I have it set up to make sure that it's the way that it's supposed to be. So let's copy this. Well, I mean, you can't copy it, but I'll explain everything once I get it going. Vector 4 vertices dot, oh, I called that vertices, didn't I? Yeah. Position. So this would be, is that Yes. Position. Wait. Position dot Z. Why in the hell? Oh, I was using 3-dimensionals, that's why. Set that to 0. That is screen toss. I believe pixel scale is the same. Alright. Got that. Put that right there. We don't need world position at all anymore. So we can just get rid of that thing. Let's out the color. Put it up here. Okay. Let's see what happens. Oh, absolutely nothing. Because I don't have anything calling anything. God, what is wrong with me? Okay. GUI.prepare. Something going on right here. And saying that it cannot bind. I initialized it, right? Yeah. GUI.init. Oh, because it... Aha. There we go. I need to cache that. Alright, so now that we have that, say GUI.prepare, and then in here, we could do whatever we want. So I will actually just call GUI.drawTexture, and it's actually called text. Call in a new rect, and I will say 0, 0, because I want it to start at the very far corner. I want it to be 100, 100, just like how we did before. And then after all that, I need to call GUI.unbind. Let's see what happens. Nothing. Hmm. Let's see this. GL position equals projection times vector 4, 0, 0, 100, 100. position times 100 0. I have it set like that. I think I did. Just to debug this, just to see if why can't I do that? Geo position equals times back 4. Ooh, so I have something else messed up in here. Passing the texture chords. Now see what's going on. Because this will tell me if there's something in the shader that's messing up. Or, okay. Okay, so I have something ding-donging around. I'll be right back. And I found it. It was this right here. That's all I was missing. It's always got to be one stupid, silly little line. So I left this how it was. Yeah, so go into GUI, go into the prepare method. At the very end, we just need to bind the mesh. That's it. All right, so back to our Vertex Shader. So I'll explain what I did. Uh, so basically we're taking the projection for the position. We're taking the projection matrix and we're multiplying it by uh, the position where we want it to be. So position is actually, we don't even need this. Offset. Okay, we do need offset. Okay, so we take the position of the vertice and we multiply it by the pixel scale. So how big we want it to be, which will be the width and height of the rectangle that we're passing in right here. So it'll be 100, 100. And so we take the position of the vertice, multiply it by the scale and inside of these, and then we're going to add the screen position, where on the screen we want it to go. And then of course z value of 0, w value of 1. So that's pretty easy to understand. Now the texture coordinates, on the other hand, so instead of saying UV chords equals texture chords, now we're saying that the texture chords multiplied by the size of the offset plus the position of the offset. So the mathematics is exactly the same as what you see right here. It's exactly the same. It's just offsetting it. So we're taking the texture coordinates, which is what 0, starting in the corner, going to the edge. So the normal full image texture coordinates, and then we're multiplying it by the size of the offset that we're telling it to offset it by. So right now we're just saying draw texture, so we're just drawing the whole thing. But whenever we use draw texture with texture chords, we're wanting a little piece out of it. So the size of this little piece. So it'd be like 0.1 or whatever it is you're passing in. And then we need to add the position of the offset. So say this little tiny zero point 0.1 by 0.1 area that we're wanting to render. Say we want that to be in the middle of the image. Um, it'll add that position value. So then when you run it, you will get the exact same thing that we got before. And I know this episode is very long, but we we got through a lot of stuff. Reorganizing, preparing for GUI. We're full on set to just murder UI and the editor, and we're going to tear through a lot of stuff these next few episodes. So this episode was big, so our following episodes will not be. And that's why I didn't add it onto the texture class episode. So now that we've got regular draw texture and we see that we're drawing it, now we're going to go GUI dot draw texture with texture chords. Now we're going to pass in text like before, new rect, and I'm going to put the X value at 150 and the Y value at 150. That way we're in the bottom right corner of this first texture that we're drawing over here. And I'm going to make it the same size, 100 by 100. Now the UV, 0 is like the left, 1 would be the right, or 0 is nothing, 1 is everything, in a sense. So let's get this popping. We'll go new rect. I will draw the corner, and let's see. Yeah, I have it up. So it's 1, 2, 3, 4, 5, 6, 7, 8. So 128 F divided by 8F. And then the same 128F divided by 8F. And if my brain is not fully fried, which it probably is, it should just be one square. So each one of these is 128 divided by 8. Hey, buddy. All right. Actually, God, I am just screwed up. Let's just render 25% of it. Jeez. Let's get this over with. So this would be 25%. So now if we pass that in, now we should get, yes, 25% of the top left way down here. So now we can actually use texture atlases and awesome stuff like that. So we will get into all of that this next upcoming episode, where we will be creating the font class. And we are going to be using um, TTF files. We're not going to be using any of this other crap where you need external applications. None of that. We're going to import TTF files. We're going to generate our own font at runtime. And we're going to render it onto the screen how it should be. Um, and then further episodes, we're going to create boxes and all kinds of cool stuff. So I think you guys are going to like the upcoming episodes. So to give kind of a example of what we're going for, this is my C3 effects IDE that I built for Construct 3. Now keep in mind this is pure Java. It's it's not my own GUI, but it will look very similar. But this is kind of what we're looking at. We're going to have it's going to be split up exactly the same. You're going to have one window up here, one window down here, then you're going to have your uh, God, I can't even think right now. Your debug right here. So if you click on it, it's going to pop up a debug window. And you're going to have your variables over here just like I do right now. So like in here, if I just create a variable, let's say uniform low p float. Uniform low p float, uh, I don't know, desk, whatever. So then if I refresh the variables, we've got it right here. We're going to be doing something very similar to this, except for we're going to be using our own GUI system. So right here, instead of the, my actual IDE section, this will be our window, our screen to actually see. So that'll actually be really, it should look nice. I think it will. Let's see, we will have it'll show us everything that's wrong. Uh, so, thanks for watching, and I will see you in the upcoming episodes. Thanks.